Hey guys, today we're going to talk about chord segments in a circle and a nice little theorem that goes along with them. So first off, let's define what a chord segment is. A chord segment, well, that is going to be a segment of a chord. So if a chord is divided into two pieces, like take the chord AC here, it's divided into two pieces, AB and BC. Those two pieces or segments are both chord segments. So AB is a chord segment and BC is a chord segment. They're segments of the chord. And the theorem we're going to talk about with this today is if we have two chords that intersect in a circle, like AC and ED, then the product of their chord segments are going to be equal to each other. And that means that, like AC, the chord segments that it's broken into are AB and BC. So the product of AB and BC, well, that's going to be equal to the product of the chord segments of the other chord. So EB and BD. EB times BD. So you take the two chords that are being obviously split into different segments here, they're chord segments, and the product within that chord of its two segments is equal to the product of the two segments in the other chord. And we're going to go through a quick little informal proof of this and how we can show it. So we need to show that this is true based upon this information. And those chords don't have to be the same length, like AC doesn't have to be equal to ED, it can be any two chords. So we need to show, or think of a way we can show this. So I'll write that as a reminder, what we're trying to show. AB times BC needs to equal EB times BD. Okay, so what we can do for this is, well, we can draw a couple of segments here. We'll draw DC and we'll draw AE there. And what this does for us, well, let's look at the relationship between angle A and angle D. If you look at angle A and angle D, angle A and angle D, well, from some theorems that we know in the past with circles, some relationships that we know, these two angles are actually congruent. And the reason why is they both intercept the same arc. Like angle D, that intercepts the arc EC, and angle A also intercepts the arc EC. So these two are congruent to one another because they intercept the same arc. And you also could say the same thing about angle E and angle C. Those are congruent to each other because, again, those two intercept the same arc here. They intercept, well, angle E intercepts the arc AD, intercepts that arc, and C intercepts AD as well. So we have those two pairs of congruent angles, and from that, well, we have two pairs of congruent angles, we can simply say that we have two similar triangles. We have triangle ABE is going to be similar to triangle, well, the A corresponds with D, so D, the B will correspond with B, and E will correspond with C. So triangle DBC, we would know that from angle-angle similarity. We also could have used vertical angles if we wanted to, but I'll use the circle relationships we know. So we know these two triangles are similar, and based upon similar triangles, well, we would know that AB over, well, its corresponding side, so the ratio of AB to DB is going to be equal to the ratio of, well, let's use EB down here, EB to BC. And then, now that we have set up the ratios, we know this by the definition of similar triangles. You can simply find the cross products here, and you end up with AB times BC is equal to EB times DB, or BD as we wrote up here. And there we go, we've shown that this relationship exists. So given two chords in a circle, if they intersect one another inside the circle, then the product of their chord segments are going to be equal. And we'll do a little example of this just to see how it works. Find the missing side. Okay. And what it's saying for us. So, let's take that. Let's take one right out of the book. we'll take this first one. We have chord AC and chord ED, and this is point B in the middle. Yep. And we are given that, let's color code a little. We're given that this length is 5, BD has a length of 10, BC has a length of 12, and EB has a length of X. We want to find the value of X. So notice these are two chords. They're intersecting in the circle. So let's go ahead and use the relationship we know. We would say AB times BC equals EB times BD. We have the same point, so we have the same relationship shown up here. Alright, so AB, that's 5, times BC is 12, equals 10 times X, so 60 equals 10X. So X we should get here as 6. So that would be your length of EB would be 6. And that's how we can use this. Notice in the end here, AC has a length of 17, ED would have a length of 16 in total. Again, like I said earlier, the chords don't have to be the same length, but the product of the chord segments will end up being the same. You can set up that nice little relationship that we have. Alright, that's all we have for today. Have a good day, guys.